In this video, you will learn how to solve this Olympiad exam question. We are asked to solve for x plus y. As we solve this video, come to see how we are going to apply the algebraic formula in getting 4 different solutions to this question. Don't forget to give this video a thumbs up. Also, subscribe to my channel for more unique mathematics solutions. Now, let's consider these two expressions as equation 1 and equation 2. So we'll have x squared minus y squared to be equal to 24, considered as equation 1. And then we'll have xy to be equal to 35, considered as equation 2. Now, to solve these two equations, we need to first of all consider equation 1. From equation 1, we are going to look at the expression x squared minus y squared equal to 24. How do we simplify this expression? Now, to simplify this expression, let's look at the expression on the left-hand side as a difference of 2 squared. If we consider it to be a difference of 2 squared, this will give us x plus y, and this is going to give us x minus y, and both of them will be equal to 24. Great. Now, to solve this question further, what do we do? Let's consider taking the square of both sides. If we take the square of both sides, we'll have x plus y multiplied by x minus y, and this will be all squared equal to 24 squared. Now, in the bit of solving this question, we're going to take the square of both sides. If we take the square of both sides, these two expressions having one common square can now become x plus y all squared multiplied by x minus y all squared, and this will be equal to 24 squared. This is mathematical. I haven't done this. I want us to consider a law, an algebraic law. Remember, I said we'll be using some series of algebraic formulas in solving this equation. Now, from that algebraic expression, if you have a plus b square, this can be equal to a square plus b square plus 2ab. Now, what if it is negative? Then we are going to have this to become a minus b all squared, and this will become a square plus b square minus 2ab. Great. Now let's apply that to that expression. If we apply that to that expression will now give us x squared plus y squared plus 2xy, right? And then we'll have x squared plus y squared minus 2xy, and this will be equal to 24 squared. Great. So, having done this, what we simply need to do next is to recall the expression we had earlier on. Recall from equation 2 that xy is equal to 35. So we are going to insert the value of xy into this expression. So we'll have that to become x squared plus y squared plus 2 multiplied by 35, and this will be multiplied by x squared plus y squared minus 2 multiplied by 35, and this will be equal to 24 squared. Great. So let's simplify this further. To simplify this further, we'll only expatiate, and that will give us x squared plus y squared plus, this is going to give us 70, and this will multiply x squared plus y squared minus 70, and this is equal to 24 square. Now come to look at these two expressions. You come to see that these two expressions is typical of difference of two squares. And why do I say that? Those two equations will give us x squared plus y squared all squared, right? Minus 70 squared, and this will be equal to 24 squared. So let's expand this. We are going to consider adding 70 squared to both sides. So if we add 70 squared to both sides, we'll have x squared plus y squared all squared to be equal to 24 squared plus 70 squared. Remember, if you add 70 squared to the left hand side, it will become 70 squared plus minus 70 squared plus 70 squared. That will give us 0. So if we expand this further, we're going to have this to become x squared plus y squared all squared equal to 24 squared is going to give us 576 plus 70 squared is going to give us 4900. So if we add that, we are going to have 5476, right? And this is going to give us x squared plus y squared and all what square. So what do we do from here? To simplify this, we are going to simply take the square root of both sides. So let's take the square root of both sides in order to clear the square. We'll have x squared plus y squared all squared, right? So this will clear this, as we'll have this other side to give us plus or minus the square root of 5476. Great. So x squared plus y squared will be equal to square root of 5476 is going to give us plus or minus 74. So we have two expressions. From that point, we are going to have two expressions. The first expression we'll have is x squared plus y squared, and this will be equal to plus or minus 74. Now recall initially that from our equation 2, xy is equal to 35. So we have these two expressions. How do we come to find the value of x plus y? Because that's what we are looking for. Now let's go back to that expression. I want you to recall an algebraic formula. From the algebraic formula, we were told that a plus b square is equal to a square plus b square then plus 2ab. We've done this algebraic formula formally. Now if we apply that to this, we will have x plus y square. This is going to give us x square plus y square plus 2xy. And recall, what we are looking for is the value of x plus y. Now from this algebraic expression we have put here, you're going to see that we have x squared plus y squared already has a parameter 74 and xy is 35. So we'll simplify or substitute that values into this expression. So we'll have x plus y squared to be equal to, this is going to give us plus or minus 74 plus this is going to give us 2 multiplied by 35, right? Great. So this expression is now going to give us plus or minus 74 plus 70. So x plus y all squared can give us that expression. So we're going to arrive at two expressions from here. The first expression will have x plus y all squared to be equal to minus 74 plus 70. And the second expression, we're going to have x plus y squared to be equal to plus 70 plus 70. Now from these two expressions, plus 74 plus 70, from these two expressions, we are going to solve for x and y. Now from the first expression, you come to see that we have x plus y all squared to be equal to negative 74 plus 70. Is going to give us what? X plus y all squared will be equal to negative 4. So we're going to take the square root of both sides to find the value of x plus y. X plus y all squared is equal to plus or minus the square root of negative 4. And from that expression, x plus y is equal to, because this will clear this, and then we'll have x plus y to be equal to plus or minus square root of 4 multiplied by negative 1, square root of negative 1. And recall, from the complex number, square root of negative 1 is equal to imaginary. So we are going to have that expression to now give us plus or minus square root of 4 is 2 imaginary. So the value of our x plus y is equal to plus or minus 2 imaginary. That is the first two values of the values of x plus y. So let's go back and look at the second expression. X plus y squared equal to plus 74 plus 70. So we'll have x plus y squared to be equal to plus 74 plus 70. What would that give us? This will give us 144, right? So x plus y all squared will be equal to 144. Now let's take the square root of both sides. If we take the square root of both sides, we'll have x plus y all squared, square root of x plus y, then we'll have a plus or minus square root of 144. So what would this give us? The value of our x plus y will be equal to plus or minus 12. Great. So the four different solutions to that expression is we're going to have our x plus y to be equal to plus 2 imaginary minus 2 imaginary. We're going to have minus 12, and then we'll have our plus what? 12. These are the four solutions for the value of x plus y we have that are requested, that we are asked to look for. From that expression, you can come to see that the value of x plus y is equal to 2 imaginary plus or minus 2 imaginary and plus or minus 12. I know you did enjoy watching this long solution, Olympiad exam solution. Don't forget to give it a thumbs up. Also, share this video with your friends and colleagues. Thanks so much for watching, and bye-bye for now.